In this video, we will look at how to calculate the expected value. The expected value of a random variable is denoted by E of x. It is the average value attained by the random variable, and this is also referred to as the mean. The expected value of a random variable may be calculated by multiplying the random variable by its probability. We will look at an example. Now, let's say we are asked to calculate the expected value of rolling a die. Remember, there are 6 faces on a die. So if we roll a die, there are 6 possible faces that we may get. That is 1, 2, 3, 4, 5, or 6. What we will do is we will take the probability of obtaining a 1, which is 1 over 6. Probability of obtaining a 2, which is 1 over 6, because each face is likely to occur or to appear. Each of them probability is simply 1 over 6. So this is how we work out the expected value. So the expected value, that's E of x, will be equal to 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times, it's going to be 5 times 1 over 6. Yes, here is this. It's 5 times 1 over 6 plus 6 times 1 over 6. All right, so let's work these out. So 1 times 1 over 6, that's 1 over 6. 2 times 1 over 6, that's 2 over 6. 3 over 6. 4 over 6. 5 times 1 over 6 is 5 over 6. And 6 times 1 over 6 is 6 over 6. And that will give us a total of 21 over 6, which is the same thing as 3.5. So therefore, the expected value of rolling a die is 3.5. Now let's look at some other examples. Now here's another example. We're told that in a game, these numerals are printed on identical blocks, and these blocks are placed in a drum. One block, the block is drawn at random, and the numeral is recorded. The block is then returned to the drum, and a second one is selected from the drum. All right, so we're told here to find a set of ordered pairs, which is the sample space for this experiment. And we are given these conditions. We're told that if the first number selected is larger than the second one, then the two numerals should be subtracted. All right, so if the first one is larger than the second one, we're going to subtract the second one from the first to get the discrete random variable. However, if the second number is larger, then we are going to add them together in order to get a discrete random variable for this experiment. Good. So if the second number is the larger one, then the two numbers should be added together to get the discrete random variable. And then we're going to create a table to show the discrete random variable along with the respective probabilities. All right. And we are also going to work out the expected value. All right. So let's head over to Excel where we'll do this working out. All right. So this is our question. So first of all, we're going to write down all the possible ordered pairs. So given that block is selected at random, and then it's recorded, and we are told that it's placed back into the drum. All right, and then another one is selected. So let's see the different pairs that are possible for this. So the first number that is selected, perhaps it's a 2. And after the 2 is selected, then we would have returned that to the drum. So it's possible that the second one could be a 2. All right. We could have 2, 4, 2, 5, 8. Next set that we could have is, first one could have been a 4. 4 could be followed by a 2. 4 could be followed by a 4 because we would have returned the number into the drum. Next one could have been 4 followed by a 5. 4 followed by 8. Next one could have been a 5 followed by a 2. 5 followed by 4. Of course, 5 could be followed by 5. Next one could be 8 followed by a 2. Then we could have had a 8 followed by 4. 8 could be followed by 5. And of course, 8 could be followed by 8. So those are all the possible pairs that we have. If you count, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16. So we have 16 of them. All right, so we have 16 pairs, and those 16 pairs form the sample space. All right, now let's go down to the random variable. Now we're told that if the first number recorded is larger than the second number, the two numbers should be subtracted to get the discrete random variable. The discrete random variable is identified by x. All right, you should know that by now. However, if the second number is larger, then the two numbers should be added to get a discrete random variable. All right, so we have two conditions that we're going to use to get a discrete random variable. All right, so if the first number recorded is larger than the second number, then the two numbers should be subtracted. However, if the second number is larger or equal to the second number, let's include that case. All right. So if the second number is larger or equal to the first number, then the two numbers should be added together to get a discrete random variable. All right, so let's start. So in this case, the two numbers are the same, so we're going to add them together to get a discrete random variable. So 2 and 2, so be 4. All right, in this case, we have the second number being larger, so we're going to add again. So we have 6 this time. All right, let's keep a track as to the amount we have. So we have 1, 4 so far, 1, 6. All right. So now the second number is larger, so we're going to add. So this is going to be a 7. So we have 1, 7 so far. Again, the second number is larger, so we're going to add. So we're going to end up with a 10. And that's 1, 10 so far. And here the second number is smaller, so we're going to subtract. So we're going to end up with 2 here. And we have 2, so 1, 2 so far. 4 and 4, both of them are the same. So we're going to add. So that's going to give us 8. So far, we only have 1, 8. All right, so we have 4 and 5 here. Since the second number is larger, we're going to add. So that's going to be 9. So we have 1, 9 so far. All right. 4 and 8. The second number is larger, so we're going to add. That's going to give us 12. That's 1, 12 so far. All right, so we're at 4 and 8. Now we're at 5 and 7. Since the second number is small, I'm going to subtract. So 2 from 5, that's 3. All right, so we have 1 3 so far. All right. We have now 5 and 4. And since the second number is smaller, it's going to be 5 minus 4, which is 1. And there's just 1 so far. And then we have 5 and 5. Both of them are the same. So we're going to add, and that's going to give us 10. So we are now at 2 tens. So we have 2 tens. All right, good. And we have 8 and 2, so we can subtract those because the second one is smaller. That's going to be 6. Do we have any 6? Yes, we have a 6. So we have 2 6s. All right, good. Now we have 8 and 4. All right, so here we have 8 and 4. 4 is smaller than 8, so we're going to subtract. So we are now at 4. So we have one more 4. So we have 2 4s. All right, so we have 8 and 5. Now 8 and 5. Now, since 5 is smaller than 8, we're going to take out 5 from 8. That's going to leave us with 3. All right, yes. So we have 2 3s. And we have 8 and 8 being 16. So we have 116. All right. So what we're going to do now is we are going to record the probability of each of these. So let's look how many times we have 4. We have 4 there 2 times. Therefore means that since we have 16 different pairs, the probability of the 4 is going to be 2 out of the 16, all right? Because we have 2, we would have seen 4 2 times. We have seen 6 2 times, so the probability is going to be 2 out of 16. Probability of 7 is going to be 1 out of 16. Probability of 10 is going to be 2 out of 16. Probability of 2 is going to be 1 out of 16. Probability of receiving 8 is going to be 1 over 16. Probability of receiving 9 is going to be 1 over 16. Probability of receiving a 12 is going to be 1 out of 16. The probability of receiving 3 is going to be 2 out of 16. Probability of receiving a 1 is going to be 1 out of 16. Probability of receiving a 16 is going to be 1 out of 16. All right, so there it is. So these are the probabilities. So now we're going to work out the expected value. Remember, the expected value is found by multiplying the random variable x by the probability. All right, so expected value of x will be equal to, so start with the first random variable. All right, so we're starting our first random variable. Let me start this row. All right. So the first random variable we have here is 4. So it's going to be 4 times 2 over 16 plus the next random variable is 6. So it's 6 times 2 over 16. Next random variable is 7. So it's going to be 7 times 1 over 16. Next random variable is 10. It's going to be 10 times 1 over 16. Next random variable is 2. It's going to be 2 times 1 over, no, for 10, 10 should be 10 times 2 over 16 because that's the probability for 10. Let's just correct that. It's 2 over 16 for 10. All right. And now we are at 2. So for 2, it's going to be 1 over 16, 2 times 1 over 16. Plus 8 times 1 over 16. Plus 9 times 1 over 16. Plus 12 times 1 over 16 plus 3 times a 3, it's 2 over 16 times 2 over 16 plus 1. So 1 times 1 over 16. And finally, we have 16 times 1 over 16. All right. Yeah, good. Let me just adjust this a little. All right. So now we can continue to work out the expected value. And you probably could guess what you think the expected value is going to be. Let's see. So our expected value in this case is 5.75. All right, so that's the expected value given this situation. All right. So look at the condition that is used to select the random variable. And this is the expected value that we have, 5.75. Great. Now let's look at another example. So here's another example. Now we are told that in a game we have the same numbers, 2, 4, 5, and 8. These are printed on identical blocks which are placed in a drum. When a block is drawn at random, the numeral is recorded. The block is not returned to the drum. And a second card is drawn at random. So first of all, we're going to identify all the possible pairs that will form the sample space. And the next thing we're told is that the two numerals are multiplied, actually multiplied, and the product is recorded as the as a random variable. So the two numerals recorded are multiplied, and the possible values of the product that will form a discrete random variable. All right, good. So let's look at the different pairs that we may have from this. So remember, the number is removed from the drum, but it's not returned. So in no instances will you have the same number appearing twice. So you won't have anything like a 2, 2, 4, 4, 5, 5, or 8, 8. All right, so you may have a 2. So it's not possible to have 2, 2. So you may have 2, 4. You may have 2, 5. You may have 2, 8. You may have 4, 2. But you can have 4, 4. You may have 4, 5. You may have 4, 8. All right. You may have 5, 2. You may have 5, 4. Can't have 5, 5. You may have 5, 8. Right. You may have A2. It may have 8, 4. It may have 8, 5. But you can't have 8, 8. So those are the different pairs. Those are all the possible pairs that we may have under this condition. Let's see how many pairs we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 pairs. Now to get a random variable, x, we're told to multiply the values in the pairs. So it's going to be 2 times 4, it's going to be 8. So far we have 1, 8. 5 times 2 times 5, that's 10. We have 1, 10. 2 times 8, that's 16. 1, 16. 4 times 2, that's 8. So we have a second 8. 4 times 5, 20. We have 120. 4 times 8, that's 32. So we have one value for 32. 5 times 2, that's 10. So we have a second value for 10. 5 times 4, that's 20. We have a second value for 20. All right, 5 times 8, that's 40. We have 140 so far. 8 times 2, that's 16. We have a second value for 16. 8 times 4, that's 32. So we have a second value for 32. 5 times 8, 40. So we have a second one. All right, so in this case, each of them is there twice. All right, so let's work out the probability. Therefore means that the probability of getting an 8 is going to be 2 out of 12. Probability of getting 2 out of 12. All right. It's fine. 1 over 6 is the same thing as 2 over 12. I just wanted to keep it as 2 over 12, but it's okay. Probability of getting a 10 is going to be 2 out of 12. Same thing as 1 over 6. Probability of getting 16 is going to be 2 out of 12. Probability of getting 20 is going to be 2 out of 12. Probability of getting 32 is going to be 2 over 12. Probability of getting 40 is going to be 2 over 12. All right, so those are the probabilities. Now to work out the expected value, so the expected value is going to be the random variable multiplied by the respective probabilities. All right, so expected value of x equal to, so we have the first random variable is 8, so it's going to be 8 times its probability, which is 1 over 6. Remember, 1 over 6 and 2 over 12 is the same thing. Plus 10 times 1 over 6 plus 16 times 1 over 6 plus 20 times 1 over 6 plus 32 times 1 over 6 plus 40 times 1 over 6. Okay, so that's going to give us the expected value. All right, so let's compute this. All right, so in this scenario, using our expected value formula, we realize that we get a total of 21 for the expected value. All right, so that's how we go about working out the expected value. Thank you very much for watching, and I hope you find this helpful.